Hello everyone, welcome to another new video, and in this we are going to see how to write a 8085 program. It is basically assembly level program to find addition subtraction of two 8-bit hexadecimal number. Already you might have done this, but here we are going to use a very special way of understanding these programs. Here we are going to deal with the addresses. Okay, and in C programming already you might have studied what are pointers. Pointer is a variable. It's a variable which stores address address of another variable. So we'll see how we'll be doing that one. Now for adding or subtraction, first we'll be doing adding. This will be 11th A program. We'll be doing addition of two numbers. So the first thing that we do is, now let's imagine that there is a memory. In the memory we have got 8000. This is hexadecimal address, 16-bit address. Okay, this is 4 bit, 4 bit, 4 bit, 4 bit. So total it is 16-bit address. In this address we are having around 34. This is a number that I am taking just for a explanation. In 8001 I am going to have 75. Okay, I have taken two numbers. In 8002, 8003. You can see these all are empty as of now, means there is nothing in this. So your first step while solving this question, in the step 1 you are going to load this particular value in one of the registers. Okay, but if you look at the register size in the 8085, size of A is 8 bits, size of B is also 8 bit, size of C is also 8 bit. So if you go like this, only all the registers are of size 8 bit. So what we will do, we'll use pairs. We'll use here HL pair. This is 8 bit and this L is also 8 bit. So these two are combined and we'll be storing this 16-bit address in these two registers. So in the step 1, HL pair will be set with the address 8000. So after setting, now value in the HL pair will become M. So M is nothing but what? The value that is present in the HL pair. In this case, what is the value in the HL pair? It is 34. So M becomes 34. Right. So you can understand this M is basically the value present in HL pair. Whatever is the address in the HL pair, from that it will bring the value and it will store in the M. That is done internally. You need not worry about that. Now I am going to assign this M equal to A. Then what I will do, I'll just increment the HL pair. HL pair increment. HL pair increment, it means I am going to make this 8000 as 8001. Okay. So HL will become what? 8001. After HL becomes 8001, after HL becomes 8001, now what is there in the memory value? Memory is, again you know that it is HL value in the HL pair. So it becomes 75. Now what I will do, I'll say add M. If I say add M, this is going to identify what is the content in the accumulator, which is 34, and it is going to see what is there in the M memory as of now in the HL pair. So it is going to add both of them, 34 and 75, and you are going to get 109, right? If you consider these are decimal values, you will be having 109. Otherwise, if you consider this as a hexadecimal values, 34H, 75H, then you are going to have a value which is 789A, A9H. So this is the value you are going to get. But the actual problem that you will face here is in case of larger number, maybe like A7 3 okay 8 5. When you add this, of course this is going to be 7 8 9 A B C. So you have got C here. Here, if you observe this carefully, I have got A here already, which is equivalent to 10, 10 8 18, 15 is F, 15 is F, 16 is a larger number than F. So, in such cases, what will happen is it will go back to 0, 1, 2. 17 is 1. You'll get 2 here and you'll get a carry here in this side. So, in the case of larger numbers, you are going to have the carries. Okay. And in this question, you are going to learn how you will deal with such carries. For bigger number, it will be a bit difficult. So, we'll see how we can go with carries. We'll just observe all of this. You can see I have just written one first step here, second one, third one, fourth one, fifth one. Okay, now we will start writing the code according to this whatever we have written. In the first case, we are going to store HL with the address. Okay, so how will you do that? If you come here clearly, you will be able to see that we have got a mnemonic XL load the registers immediately, and this is HL pair. We have got 8000 H. Okay, now let me HLT halt. Let me halt. After doing this one, I am going to halt. This is because to show you exactly what is happening in the this case. If I go to assembler execute, you can see it has successfully executed, and you can observe here HL. This is HL pair 8000. If I write 8001 01 also, you will see execute. You can see it has become 8001. In this way, we can actually store the address values in the HL pair using LXI. Okay. Now, in the next case, if you see, I have to move this value 45. I have got 45 here. I have to move this 45 value to the accumulator. So how will you move that one? I have told you this HL value in the HL will be stored in M. We'll use this M. It happens internally. We need not do it manually. Now I'll say move move A comma M. Now whatever is present in the M will move to A. Now we'll just execute this line and we'll check execute. We can see I have got 45. Okay, 45 is a decimal. I'll just write 45H. I have written 45H, that is nothing but 69. We come here, you can see it has become 45. It means I am moving this particular value into accumulator by writing this one. After that, we are going to do the next process. If you come here and see AM, I have done this one now. Increment HL pair. The reason behind that is now at present HL pair is 8000. I have to move my pointer to 8001. Now as of now it is 8000. I have to make it 8001. So how will you make it 8001? INX. See, it is not INR. INR will increment your individual register, but INX will help you to increment the addresses that we are speaking about. So if I say INXH, now I'll just execute and show you what will happen. Execute. You can see I got it as 8001. It means now this pointer is pointing at 8001, and if I try to move this particular value, now 30 it is, let me write 30H, it is 48. Now I'll just try to move that value into my B and check whether it is working or not. But before that, let me add it. Add add m means at present what is the value of m? Value of m is decimal 48 or 30 hexadecimal. Okay, now if I say add m, it is going to add this 48 and 69 and store it in the accumulator. Okay, so you can see now, I'll just execute this one. Execute. You can see initially a value was 69. Now this 75 is basically a hexadecimal value. Now when I add these both 69 and 48, what I am going to have? Let me come here and try adding 69 and 48. So it is 17, 6, 7, 8, 9, 10, 11. So it is 117. We'll see what is 117 is equal to. If decimal is 117, to hexadecimal you can see it is 75, 75. So done. I hope you are able to understand this part. In this way, what is happening? This m stores the value that is present in the h address. In HL address, I have got 48, so m is equal to that. Alright. Now I'll try to store this m. I'll try to store that a into some address. So before storing that one, what I will do is I'll increment inxh. After executing this one, you can see what will happen. You can see it has become incremented. Now I will move a into m, means I am going to move whatever is present in a into m. This m is nothing but the value in 8002 as of now. In 8002 it is 0. This a value 75 will be moved here. Okay, I'll go to assembler, execute. You can see now when I add these both, I am going to get 117. Now in case if I change this value to uh, maybe 70. Okay, what is the expected value here? 8 will come here and 1 1. So 118 is supposed to be here. We'll just go and execute. You can see it is 118. In this way, what we will do in the first case, we are going to load this address into HL pair. Then next one, value in the HL pair will be present in M. So I'll move that memory value into accumulator. After that, I'll increment HL pair, and then I will add this one to this. After that, the value will be stored in the accumulator, and I can move that accumulator value to. And see, this can be a very simple program for this question. But here I said that there is a very small issue. What? The issue rise when the numbers are larger. Numbers are larger. Maybe if I am trying to add FB and uh, 0A. If I add both of them, you can see this is 12, this is 11, this is 10, this is 11. Right. So this is going to become what? 21. Okay. So you will have a carry here. Okay. And in such cases, after having carry, so 16 is 0, 17 is 1, 18 is 2, 19 is 3, 20 is 4, 21 is 5. So you'll have 5 here, and then this will give you 0 and 1. Okay, this is addition basically. In this case, if it is crossing 256 value, what is going to happen is it is going to have a carry. We'll just try to add these both values. So 0 FB H. Okay, that is 251, and then 0A 0A 00 A A H. Right. So that is nothing but 10. When I add these both, load, assemble, execute, you can see I'm getting just this 5. We're getting just this 5. Then where is this one? This one has got into this carry value. We can observe here. If I just reset all the flags and if I go and execute now, execute, you can see carry is becoming 1. It means 5 is coming here because it can store only how many? 8 bits, not more than that. It can store only 8 bits. This is 4 bit and this is 4 bit. Only 8 bits can be stored. The remaining value goes into carry. Now I have to make sure that I will store that carry somewhere here in this part. So to do that, what I will do is I'll just come here. So I will just move the value of carry. Jump if carry, store in B. Okay, I'm going to store in B. So store in B is nothing but INR increment B. So before incrementing B, you should know that you should have initialized B also. So we'll just go and move immediate B with the value 00H, right? Initially B value will be 0, right? And then we are going to incrementing B. I'll show you what will happen here. If I just execute this part now, assembler execute, you can see jump if carry increment B, but you can see that B B has become 1 here. Okay, you can see clearly B has become 1. So I want to store this B, but there is a issue. I'll just show you. I'll say 05. Now when you add these both, execute, still I am seeing this B is equal to 1, even though carry is not 0. It is 1 because when it comes here, after this step, if the carry is not 0, it will not execute this, but it will execute this line also. So what we will do is we will write jump if not carry. Jump if not carry, I'll write skip. And this increment B will be done here, and then I'll write skip here. Control V, and skip is nothing but our NOP, no operation. I don't want to do any operation. You can see when there is no carry, I will skip incrementing B. Okay, so we'll just try to execute this code. Assembler execute. You can see now B is 0 0. 5 plus 10 is equal to 15. Now here carry will come. Since there is no carry, I don't have anything. Now if I write a value 251, okay, I have written 251. If I add them, obviously I'm going to have a value which is more than 256. So if I execute this part, you can see now B is becoming 1. And now what we will do is we will try to store that B into this memory here. So for doing that, I will do this INX increment H. Now it is 8002. I have to point it to 8003. So this will point to 8003. Then next I am going to move to M from B. From B I am going to move that value to this memory address here. Okay, so you can see this is our number 1, this is second number, this is our sum, and this is carry. Okay, F5. So we'll try to run this, execute. You can see now 8003 is becoming 1 because when I add 251 and 10, it is going beyond 256, which is more capacity than this 8002. You know that all these addresses will be able to store only 8 bits. It has stored only 8 bits, and then whatever is the carry value, we are storing it here. So this is for addition. Subtraction also, it is a very simple thing. What you will do, instead of writing add, you will write sub, subtract. Okay, now come to assembler. If I execute, you can see that I am going to store this 251 minus 10 is going to be 241, right? In case if I have 10 here, 10 here, and 251 here, 251 here, and just go and execute, you can see that I am getting 15. The reason behind this is because what it is doing, see here A was equal to 10, and then B or M value was equal to 251. Now when I try to subtract this, it is not possible. So what the system does, it will take a carry, it will add 256 in this, 256 plus 10, this is equal to 266. Okay, now this becomes 266, and whatever the carry that has borrowed, that will go into carry flag, carry flag. Okay, so 256 minus 251, so this is going to give me what? This is going to give me 15, and the same 15 is stored here. Okay, in this way subtraction happens, addition and subtraction, only that is the difference in subtraction and addition, but all the other things will remain same. And this is the code for program number 11. Okay, I hope you got it.